Welcome to a short introduction video to the module Extended Realities for Architects. My name is Markus Hudrich and I am teaching image processing and computer graphics at the Bern University of Applied Science. As a former architect, I was always interested in the visualization of architecture. And virtual reality is a new media that offers, especially for architects, new possibilities to experience their designs with a very strong feeling of presence that was not possible before. This is not only a chance for architects, but also for their clients who are not trained to read architectural plans. We at the BFH developed therefore a method to bring architectural designs out of CAD systems as easy as possible into mobile VR headsets. The speciality of VR is that two images, one for the left and one for the right eye, have to be generated extremely fast. This is the domain of game engines that are usually used to create games. We use for this purpose the game engine Unity 3D, which is free for students and for small companies with a turnover smaller than $100,000. The documentation you're looking at has several chapters, and I want to focus in this introduction video only about the chapter 4, how to create such a VR application as easy as possible. If you install Unity, you have to create an account at their website, and the installation happens with the Unity Hub that you see right now. Please make sure you install the latest long-term support version of Unity, which has the ending LTS. Please make sure that you install your operating system of your computer and also the Android package because we will install on a MetaQuest headset, which is in fact an Android device. We provide you with a project, a zipped file, and you have to add this in under the projects, add projects from disk, and this is, before you do that, you have to unzip it. Voila, MD2 Unity VR V7. Then you can add it. You see here the version with it, which it is made. You can also here already select the that we want to skip to Android as a platform. Then you can open it. It takes, for the first time, few seconds, depending on the speed of your computer, up to 1 or several minutes to open this project. So the window layout of Unity looks like this. The first thing we have to quickly check is that we really have switched to Android. Choose File and Build Settings, and then you see here that we are really on the Android. So far this is good. What I'm showing here now are two ways of building our VR application. The first one is the traditional one, which is building the app and then package and install it on your headset. By the way, we are supporting all headsets that support OpenXR, which is an open standard for VR headsets. So we are not depending on Facebook, Meta, Oculus Quest headsets. We support all other brands as well. So I connected it and I choose here refresh, and then you see here that I have my MetaQuest headset connected. So before we build, I first want to show you what we built. What we built here onto the headset is all the stuff we provide to the students, so they don't have to program any line of code. And this, we call it the viewer, okay? And in the viewer, we have multiple scenes. And the start scene is a scene where we have nothing except an environment image. That's the School of Architecture in Burgdorf, where our students are. Then the base scene is the scene where all the functionality is in it that the students will need to be to teleport, to navigate in their scenes. They don't have to touch this scene at all. And then there is an example scene with some specific informations and add-ons that can be added to any of the imported scenes. So what I'm doing now, I'm building these scenes into a viewer application, and that's what we do with this build settings. You see all those scenes here are attached into the build. We have to be sure Oculus Quest is set, and then we choose build and run, and just choose any name, MD2 Unity VR, voila, and save. And then quite a lengthy build process of several minutes starts that I will skip or shorten down. This is one of the main reasons why we don't do this for all architectural scene. This is a quite long process. If you do it several times, from the second one it is much shorter, but still it's pretty complicated. You need to have the headset connected over the USB-C cable. If we share among students a headset, this is always a hassle. So, as you can see, the build process took more than 4.5 minutes. So I can unplug the headset. I mounted the headset, and you see here I have a see-through, path-through, and I have my menu in the VR headset, and my application is already running here. It's called MD2. I quit it for the moment and show you where to find it if you start it fresh. So here on the most right icon with the 9 dots, I'm pressing that one. Normally you are here on you have all apps, and then you have to choose the unknown sources button, and if you sort by recent, then your last built application is on the top. Ours is called ND2 Viewer Quest 2022. Click on it with the finger. As you see, we don't use controllers. Everything what we want to do is done by hands. What you see that we are in the start scene. Okay, in the start scene, and if we flip one of our hands, we get a menu. Okay, if you click here on the second button, you see all scenes that are available, the 2 scenes that we just built, okay, and the scenes that will be downloaded from a server. Okay, that's how it is. I quickly just want to show you the basic method. That's why I'm starting. You can touch it with either the finger or doing a tap gesture. Finger is easier. The example scene. And now I am on this example scene. You see I have a real-time shadows for my hands. I can teleport with my left or right hand. Okay, and I set off the headset. Voila. This was the build of the viewer. So the question is now, how can we build our own scenes? And that's the major part. So we have in our assets folder an empty folder called My Scenes, and in there I'm creating a folder test. Let's say I'm the test user. Okay, and in there I'm creating a scene for another folder. Let's say it test Barcelona. Okay, why Barcelona? Because I have a test object made in Rhino, which is the Barcelona pavilion that you can see here. This is Mies van der Rohe's pavilion for the World Exhibition in Barcelona 1929. Okay, so this is an architectural design or a student education design tool. There are other tools like ArchiCAD, like Vectorworks. The process is more or less from all those systems the same. We need to export. That's why I'm choosing data export. We choose a format. There are several formats possible. We choose the FBX. We want to export the textures. We want to define some more options here. And you can, if you have more lights, you can choose here the lights. Please choose always only polygonal networks, so meshes, and that's okay. And we choose here Barcelona Pavillon from Rhino. We provide the same thing for Blender or for ArchiCAD. Now we have these files and we can just drag them into our project, which is on the Documents folder, My Scenes, Test Use Barcelona Pavillon, and here is our export. What is important, not only the FBX file but also the textures are important. We drag them, copy them to our Unity project, and they automatically get imported. It is important that you also really copy the texture folder. These are images files for texture mapping, as you can see in the background here, for example, these bricks on this cube are such texture maps. Voila. So we create a new scene in here in the folder of our Barcelona test file, and we say create new scene, name it test Barcelona. It actually doesn't matter. Barcelona. Voila. And already important is that you can flag it here as addressable. You double click it and it will be empty. It will have a default scene, a camera and a light source. Voila. If you're going to your imported FBX file, click on it and then make sure that you on the materials extract all materials so we can check them and modify them. Choose materials, extract them, create a folder, for example, materials, and these materials will be exported. On the model side, click on the model tab here. Please choose, we don't need cameras. Deselect them, but more important is generate light map UVs will be important if we will bake the lighting afterwards. Click apply. Now we can place the model in our scene. Just drag it into here. It is placed at 0, 0, 0. You see it here in the scene graph. That the model's material are not so badly imported. The first thing we want to do is we want to move it so that the start point is at 0, 0, 0. If we click here on isometric, if the model's 0 point is not there where you want to be as a VR user, and which is in our case here underneath, we have to move it. So that's what you can do by just dragging it and on. Voila. So my starting point will be here, so roughly somewhere here. What else do we need to do? Maybe we need to adapt some materials. For example, this chrome steel material, the import was not correct. Now, because we exported the materials, it is black. We don't need it as black, and we need the metallic pretty high. No, it is chrome to 1, and the smoothness, let's say, to 90%. So it looks a little bit more like voila, like chrome. Then we have our light source, which is default already in. Be careful if you have light sources in your scene. You need only one for the sunlight. I don't have a sunlight in my scene. I use this one. I want to rotate it a little bit so that I have more sunlight, something like this. We leave it for the moment with dynamic shadowing and dynamic lighting, which we will improve in a second build. Where do we want to navigate? Okay, we don't want to navigate everywhere. You can select all the objects where you want to navigate. Let's say this, the floor. Here, the clay part, maybe also the street. And for all these selected objects, we need to add a mesh collider. You just click on Add Component, Mesh Collider. Voila. And the second thing is we need to set it on the layer teleport. Voila. That's in fact everything. And now the important step is that we don't want to build it on the headset. Okay, this method of building it, which will be much faster, will build it and upload it onto a server. Important for this is that this scene is selected as addressable. Okay, that's the important thing. So as you can see, my headset is now not connected. And you choose this menu, Remote Storage Settings. To know where we upload our build, we have to add a semester ID. We have to be size one that we give you. For this course, it will be MD2-FS24, Frühlingssemester 24, and dash Vollzeitstudium FZS. The last name is test user, and the student aberration is test 1. Then we can click build and upload. And as you can see, chuck, it is extremely fast, and now it just uploaded with the spinning ball and it looks fine. And now we can test it, but my headset was not connected, so it is now on the server. So I have to put on my headset and download into our viewer that we just built before. Voila. I'm on the headset. Here we see our MD2 that we built before. I just start it, or I choose it over the 9 dots bottom in the file system. I just choose here, start my application again. I will start in the start scene. I have my fingers. I open the menu with one of the hands and I touch here the scene button. Voila, it downloads all folders that are on the server, and we just uploaded one into the MD2-FS24 Vollzeitstudium. Voila, and here is my scene. Okay, and what is my user first, and now my scene. Check. And now you see how it is downloading, and we are in our scene. Okay, we can teleport by just closing index finger and thumb. You look where you want to go. Okay, and if you know where you want to go, like there, you can open index and thumb there, and then you're there. So we can go inside. It is dynamic lighting, so the quality is not really good. The shadows are pretty pixelated, as you also can see here on my hands, but also here on the roof. This is not very nice. The speed is okay, as you can see up there, the numbers. These are the statistics, and the lowest number you see the frames per second. This you can turn on in the settings. If you don't want to see that, just show statistics off. Voila. So that was it. You can go back to whatsoever scenes. You can also, if you added a email in here, you can send to you a screenshot to that email address by clicking on this. Let's go over there. By clicking on this photo icon here, it takes 4 seconds and then it check makes an image and it will send it to from the headset that you're wearing to your email. That's how you can make screenshots. Voila, sent. And that's it. I'm stopping it because we want to make the lighting higher quality. If you look here on the ceiling, everything looks pretty flat. The indirect lighting, also the shadow, do you see that they stop over there? Back there, they stop. They are real time, so which means we could change the light and the shadows would change. We mostly don't want that, but we would actually love to have a better indirect lighting, a soft lighting, a higher quality indirect lighting, and that's what we do next. Real-time lighting is cool, but the quality in architecture is actually not really good, and that's what we want to change. This is not an expensive building. It has not so many triangles because all the objects are more or less rectangular and the triangle count is pretty low. So the speed was good on my headset, but if you have models and they quickly can get very much higher, the number of objects, the number of triangles, if you have roundish objects, the number of triangles get quickly much higher and the rendering will be more demanding on a mobile headset. These objects with dynamic lighting, the dynamic lighting is one of the most expensive parts. So we best do bake the lighting, which means our objects must be static. This only works for static object, which is in architecture the case for most objects. So we select our object, all will be set to static. Yes, change also children. Now we go save, we go for the light source and we set it either from the mode real time to mixed. In this case you will see your hands, because they are not static, they will still cast dynamic shadows, or to bake we choose mixed. On the window rendering lighting, first we need to create a new settings object. The only tab we need to open is the light mapping setting. It is faster if we uncheck the progressive updates. Everything we leave, maybe we can increase the maximum light map size to 2048. That's it, and I press save and generate the lighting. Another term is bake lighting. Okay, this can take a long time, so you don't do this every time. Okay, we bake the lighting and the shadows into the objects on additional textures. The advantage is at runtime, in real time, in the headset, the dynamic lighting does not have to be calculated. That's the major part of the cost of rendering. And the second thing, the quality of the lighting will be much higher, as you will see in a few seconds when the baking is finished. Voila. I don't know if you see it. Now, if we would rotate the light, okay, nothing changes on the shadow, as you can see. Okay. If we go into the object, you will immediately see that the quality is much higher. We have a nice ceiling. It gets darker in here. Voila. Okay. And it will be even quicker. And we press again Tools, Remote Storage Settings. We don't change anything. We just say Build and Upload. Now it's uploading. Upload completed. Voila, it took 55 seconds to build and upload. Let's see how this looks like. I put on my headset and just see how the lighting looks like. I'm opening the scene. Wait that the folder download, go into MD2FS24. test user test 1, and my scene is called test Barcelona. It is downloaded 43 megabytes from the server, and here we are. And the lighting is much better. As you can see here, the shadows, they are really nicely smooth, and voila. What we can improve is the reflections on those doors. They are not really perfect. We can improve this. We can improve also the baking quite a bit. That does not look really nice. We can improve this. There is a water pond, no reflections on the water pond. That shall be improved. Also here we can add a surrounding image of a city like Barcelona to make it more immersive. Also here the pond is not reflective. We have to improve this, but I just wanted to show you how quickly we can build and upload our own scene. Back into reality, that was my introduction, how we can create our first VR app. This is more or less what we cover in chapter 4. We cover more information in chapter 3 about the preparations in your CAD system for architects. What do we have to be aware of when we do exports there? What can we do on materials and lighting more? Chapter 6, you see the case study about this circular tower project, which is a real project from an architect's office, also a bigger project, a tower. That's what the project looked like. What do we do to optimize the render performance? And voila, that's a real example, not just a small object. That was it from my introduction to this method of uploading our scene to the server. What is the biggest advantage? The biggest advantage is it is much shorter and you can share it. All your colleagues, your students, or even maybe your clients, if you are in an architect's office, could download now this scene. They would have it. You can call them and say, let's have a look. That would be a huge advantage. Thanks for listening, and see you next time.